This is number 3 on page 595, and in this problem I have two cables that are attached to the top of a television antenna, and they're attached, it's attached on level ground. So if that's my antenna, here's the ground on each side, and the cables, one's a little longer than the other, so out a little further. So this cable is 300, and that's meters long, and this one on the other side is a little shorter. It's 270 meters. And we're given that the longer cable, so this is going to be this one here, makes an angle of 48 degrees with the ground. We have to find two things in this problem. We have to find that angle that the shorter cable makes with the ground, and then we have to find the distance between the two cables on the ground. So for simplicity, I'm going to call this side A, angle B, and I'll call this angle C. So I could use right triangle trigonometry and the 48 degrees to find this height, and then use that, these two heights, or these two lengths, to find angle B. But I can just use the whole big triangle and the law of sines here, because I have an angle. If I just dissolve this altitude, I have an angle opposite a side that's known, and I have a side opposite an angle I can find. So I'll use that. So I'll say the sine of 48 degrees is to 270, as the sine of angle B is to the length of 300. So cross multiplying 270 times the sine of angle B is equal to 300 times the sine of 48 degrees. And then we'll divide out the 270 on both sides. So the sine of angle B is equal to this ratio. So B is the inverse sine, or the angle that corresponds to that. So I'll get that B is 55, angle B is 55, and to the nearest tenth of a degree, 7/10 degrees. So I'm going to fill that in. Which will allow me to find the angle at the top here, because the second part of this problem is I have to find the length of AB. So this is opposite angle C. I'm going to call this whole side length side little c. So let's do that over here. There's two ways that I could do this. First of all, I know that this whole angle is going to be 180 minus the sum of these two angles. And so when I find that, that is 76 3/10 degrees. So I could use the law of cosines, because I have an angle known between two sides to find side C. And I also could use the law of sines again. To the same, sine of 48 is to 270 as the sine of 76 3/10 is to C. So I'm going to show it both ways. First I'll use the law of sines. It's a little easier. So using the same original ratio, the sine of 48 degrees is to 270 as the sine of the 76 3/10 degree angle is to side C. So cross multiplying, and dividing through by the sine of 48 degrees, C is equal to, and this is going to be 352 9/10 about, so we're just going to go to three significant digits, and so this is 353 meters. Now to check that, I'm going to show you that we also could have used the law of cosines, since we know this angle between these two included legs. So using the law of cosines, so this was the law of sines. If I want to use the law of cosines to solve for side C, I could say side C squared is equal to the sum of the squares of these two sides that surround angle C, minus twice their product, times the cosine of angle C, which is 76 3/10 degrees. So when I simplify this and take the square root and solve for C, I will also get 353. So you see that we could use either once we've gotten the 55.7 degree angle. So that's it. That's number 3.